My name is Witek, and we also have Simon on the call. He's one of our developers that's been with us for since the beginning of Enjin Coin and Enjin, the platform that we've been building. So we're going to be talking about scalable, programmable NFTs. I'll just go through a bit of an overview, introduce what we're all about. Then we're going to talk about non-fungible tokens, the different kinds of non-fungible token standards that are out there. We'll talk about the challenges in NFTs. And then Simon's going to do a tech demo where we'll actually jump into the platform that we've built, as well as some code of how you can actually integrate NFTs into your own projects. And we'll talk about some maybe future predictions for NFTs, and then we'll have a Q&A afterwards. So Enjin is basically, we've been around since the beginning of NFTs. We started about 4 years ago, and we were around in the space for a while. We were actually building tools for games and game developers and game players to actually socialize and interact in these large communities. But we discovered Ethereum, and we saw that there was a lot of opportunities in the blockchain space. So back in 2017, we were basically one of the first entities to actually create the concept of an NFT. And so we built this whole platform for developers that lets you create NFTs using a web interface or using code and APIs. Then you can integrate it with your software, give your tokens utility, whether it's in a game or in an app. Microsoft Azure is actually using these NFTs to sort of gamify the learning experience for Azure developers. And many game developers are using them just to either have a currency in a game or to maybe represent your character in a game or an item such as a weapon. Let's say you have a whole MMORPG game. You could actually tokenize every item and every currency in that game, and then people can actually own those things. Now, it also lets game developers monetize. So we've seen people basically doing these initial asset offerings where they create a number of game items, game characters, and then they sell them to their users in advance of the game coming out. And then when people trade and resell those things, they can actually get a cut of that. So it's a new, interesting avenue to monetize. And we also have this technology called Enjin Beam, which lets you distribute NFTs by just simply showing somebody a QR code. And what it does is it basically calls a wallet in the background that sends somebody that NFT without them having to really do much. They don't have to have any crypto. They don't have to have any experience with it. They can just receive their NFTs very easily. So let me talk about the standards a little bit. Some of you might be new to NFTs. Probably a lot of people in the world have heard of it now. There's 3 main token standards on Ethereum. So the first one's called ERC20, and this is a fungible token standard. So what that means, it lets you create currencies and fungible things. Fungible means that every unit is alike. So if you want to create a new crypto token, if you want to create a version of a stable coin or some kind of transferable currency, you would use the ERC20 standard. It has a number of functions such as transferring, giving people approval to transfer on your behalf. It also has each ERC20 token is a deployed smart contract. So you basically have to build the code for it. You give it a symbol, a name, you tell it how many decimal places it has, and then you deploy that code out. You compile it and you deploy it out onto the Ethereum blockchain. You have to pay quite a fee for doing that. But then you have this live fungible currency that anyone in the world can transact in. Now, ERC 721 is a pure non-fungible token standard. The way that this differs is instead of having a balance, like I have 100 gold or 1,000 units of gold, with ERC 721, each unit it has its own ID. So you can have the Mona Lisa, and that's a unique ID. You can have something by Van Gogh, and that's a unique ID. And every single unit is assigned a new ID. And with ERC 721, it allows you to transfer each ID individually to somebody else. and they can own it. And just as with ERC20, they can transfer it, they can give approvals to people, and they can assign metadata. So that means things like images per NFT, and descriptions and names and things like that. There's been quite an ecosystem that developed over the last few years now around ERC 721. And there's various marketplaces, there's applications that support it. There's even some DeFi projects that support the standard. Now, what Enjin worked on, we actually built the ERC 1155 standard, and this was actually developed sort of in tandem around the time that ERC 721 came out. And we needed something a little bit more powerful than just a fungible or just a non-fungible token standard. Because when you deploy an ERC20, you just get that one currency, like gold or USD or whatever you want to call it, Enjin coin. With ERC 721, you get individual units, and that's useful for unique one-off pieces of art or collectibles. But sometimes you need to have a run. Let's say you need to have 100 collectibles. Sometimes you need to mix fungible tokens and non-fungible tokens in the same project. So what ERC 1155 does, it's for any developers out there, it's sort of like a factory. It's like a vending machine. So it lets you create a new subset of tokens, and they can be fungible or non-fungible, and you can organize them in any way you want, and then integrate them into your project. And one of the other advantages is when you deploy a token, you don't actually have to compile the source code and you deploy it out for each token. Let's say you're creating a game that has hundreds of thousands of different kinds of items and variations of things and fungible currencies and health kits you can hold and whatever else you can think of. Or if you're building a supply chain where you're creating new kinds of products and you want to release them and track the supply chain, you would use ERC 1155 for that, because it lets you just create a new class of tokens and then mint them on demand in the smart contract without having to redeploy code. And you can build a whole rule set of code around that token so it can behave in certain ways. Another cool thing with ERC 1155 is it lets you do batch transfers, which actually saves a lot on costs. So if you want to send 100 people a token in one big transaction, you can do that. So we talked a little bit about the use cases. There's plenty of people experimenting right now. There's platforms, marketplaces being built all around the world where you can trade and transfer things. You can use them in DeFi, like people even fractionalize a non-fungible token. So for example, if you have a collectible piece of art that's worth $10,000 and it's an NFT, some platforms out there can actually take that and fractionalize it, split it up into 1,000 pieces, and now people don't have to pay for the entire NFT. They could own a portion of that. One of the big use cases we think is in virtual worlds ownership. The real thing that a lot of us have been living in these online virtual spaces. We've been living on the internet for decades now, and there hasn't really been a true concept of ownership. You can have an alias. You can represent yourself with an email address. You can own some domains, things like that. But really, it's been very difficult to own something and have like true ownership, where some centralized party can't just remove that item from you. I've been part of plenty of platforms and games that have shut down over the last couple decades, and I've lost the history of everything that I've done. So that's one of the main use cases of NFTs. Also, just giving the community of developers and users out there the ability to tap into the public blockchain is huge, because now you're breaking out of these walled gardens. You could be creating a piece of software or a game, and anyone who owns those NFTs can now use them in different websites, in different games, and it creates this multiverse. That's what we've been really trying to achieve at Enjin, and I think it's starting to happen. So it's pretty great. So here's an example of QR code using the Enjin Beam system. If you pull out your phone and you scan it, you can actually receive a free badger for being part of this webinar. So we've worked with Microsoft Azure for a while, and they've really helped us flesh this concept out of gamifying a community and kind of giving people something of value back. So If you participate in Microsoft events, you can actually receive these NFTs. If you do things like posting blog posts, posting some code, being part of the community, you'll potentially be eligible for receiving different kinds of badges, and then you can post them on Microsoft's showcase website. You'll be shown on the map. So you can always look back on this video if you didn't have time to scan. But yeah, anyone who scans this will get an NFT. So there are obviously some challenges, and they've been brought up in the past about Bitcoin, about blockchain, its environmental impact. And there is some truth to that. In proof of work blockchains, these are blockchains like Bitcoin and currently Ethereum, where many nodes around the world have to reach consensus. So the whole concept of blockchain is code is law. And there's a ledger that everybody shares. It's a big log of transactions and history that's been going on, and they're contained in these blocks. So when you have this giant distributed network across the globe where there's no centralized control, the way that blockchain works is that every miner has to actually solve this cryptographic puzzle. And as more miners get involved and more transactions happen on the blockchain, there's an incentive for people to mine like, for example, Bitcoin or Ether. And doing these cryptographic puzzles uses a lot of energy. So they have to run through trillions of permutations of the puzzles, solve a lot of, basically do a lot of hashing, and there's I don't know how many. It's kind of a useless puzzle that these miners are solving, but the use case of it is it's a proof of their computers having worked to do all these permutations and actually reach consensus, and they get to prove the block. So there is an environmental impact when using things like Bitcoin, but there are a lot of things happening right now to resolve this. On Ethereum, the network is actually moving towards proof of stake. So instead of solving these cryptographic puzzles to basically to verify that the block, you're going to actually have a stake of coins, and that stake of coins is actually bonded, and you may risk losing those coins if you actually do something fraudulent on the network. So that's one of the things that's happening and a lot of networks are moving to proof of stake. Polkadot is another one. It uses nominated proof of stake, and it's extremely efficient, thousands of times more efficient than Bitcoin or Ethereum. So this is going to be resolved in the future. Also, our standard ERC 1155 has things like batch transactions and this factory pattern, which actually reduces significantly the costs required to do these transactions. Obviously, there's a need for gas fees, because if we let anyone just spam the network, they would overflow the network. It would become insanely huge. No one would be able to actually run the thing. So there's a limited amount of space for each block, and people basically have to compete in the transaction fees. So sometimes when you hear about Ethereum having $50 transaction fees or $100 transaction fees, it's simply because everybody on the network is competing to get their transactions in, and the network is only allowing a certain amount of transactions in at that time. There's also user experience challenges. We've seen this talking with game developers over the last 3 or 4 years. Generally, your mainstream users don't have cryptocurrency. They might not have a blockchain wallet installed. They might just be wanting to access your application or get a collectible easily, or play their game. So we're working on a new platform called Efinity, which is going to be coming out next year, and we're going to solve a lot of these issues. Companies are going to be able to delegate their transaction fees to their for their users. They're going to be able to create accounts for users in the back end, send tokens to those accounts, and then users can then claim them in the back end. Another thing that's coming up is interoperability issues. So there's a lot of blockchains coming out. Everyone seems to have a different spin on how to do things in blockchain, and we're seeing this initial concept of this multiverse and this great ecosystem is now being divided up into these walled gardens, and simply a lot of these blockchains don't have the resources to connect outwards into every other blockchain and make themselves interoperable. So Enjin's working on a new standard, pair token standard, that is going to address NFTs migrating across blockchains, and we hope that this will bring a new revolution in terms of interoperability. So let's move on to the tech demo. We're going to go through the developer experience, Enjin Cloud, the Enjin API, and then we'll actually create an NFT crafting system using Node.js. So I'm going to stop sharing my screen here, and we'll let Simon take control.
Do you want to just show the next slide? There's the flow chart.
There we go.
Perfect. Okay, thanks, Witek. Yeah, so I can take us through a little overview of the Enjin ecosystem as we are at the moment. On that diagram you just saw, I don't have that one handy here, so if you share that back up. Great, thank you. Yeah, so we've got several components to our products, as Witek was explaining there. Underpinning everything, of course, is the smart contracts sitting on the blockchain, and we have our ERC 1155 contracts running on mainnet, Koban test network, and also our own jumpnet. So over the top of that, in order to kind of help developers and people making games access the smart contracts without having to know a deep knowledge of how to write smart contract code and deploy code and things like that, we've built a nice Graphql API layer over the top of it, and this provides access to the smart contract functions, so creating an asset, minting it, sending things like that. This is all done just through a Graphql API through our Enjin Cloud interface. And then on top of that, as we get a little bit higher level, for those people who don't know GraphQL or don't want to use it, we're going to provide the web front end. So that's the Enjin Cloud portal. You can log in, create your project on there, create an asset all through a web interface, and also mint your assets through there too. Of course, if you don't want to be using the front end as part of your game all the time, you've also got the Enjin SDKs for C#, Unity, Java, and so on. So you can integrate through GraphQL just with a straightforward library of functions that you can then use to call the smart contract. And as you see, they trickle down through the stack there, and ultimately everything ends up on the blockchain. Alongside that, we've got the Enjin Wallet apps, and there's two flavors of this. We have the Enjin Wallet mobile app, which is what most people would be familiar with. That's the thing you get off the App Store. You can sign transactions and do all your work in there. But again, because the game, when it's live, you don't want to be sitting on your phone signing transactions all day as they come through from players. We provide the wallet daemon, which just sits on the GraphQL API there, and that automates the process of receiving transactions from the API, signing them, sending them back. So it's kind of like a little app. You just fire it up, put your private key in, your wallet in, and it takes care of all your game transactions for you as it goes down. So yeah, that's just a very high level overview of how we've got our tech set up. And I can now give you a brief demo. So I think now we can switch screens. So I'm going to try this. I have prepped a video for this to make sure everything works. So hopefully we can get that through. However, I'm having some issues with sound. So if it doesn't come through, I might have to go ahead and do this live. Right then, let's have a look. If I can you see that okay? Right then, let's see if we can play this.
Not yet.
Oh, can you not see the video?
No, I don't see anything right now.
Is it just my background screen, is it?
Yeah, it's just your...
Just some stars.
Yeah.
Yeah, so I've not done a screen sharing Teams before, so you'd have to forgive me trying to work it out. Let me just try something else here. Let's try again. Right. Have we got that?
Yeah, looks better. Thanks.
Great. Right, we'll have to do it like this and see if this works.
Node.js web app.
Right, okay.
Hi there, my name's Simon and I'm the senior engineer working on Enjin Cloud. Today I'm going to take you through a few areas of Enjin Cloud and the GraphQL API used to power it. We'll start with the Enjin Cloud web interface, where we'll create a project, create and mint an asset. We'll then take a look at the underlying GraphQL queries in Postman. And finally, I've built a small Node.js web app, so we can take one of the queries and use it within the app to mint some assets. But first, let's start with the Enjin Cloud web interface. I'm already logged in here with my user account, and today we're going to be using the Ethereum Kovan network, so we can mint assets without costing any ETH or Eng. First thing we need to do is create our project. Okay, so with that created, next we need to link our mobile wallet app. So I'm going to click here, and as you can see, we need a linking code and a QR. So now I'm going to load up the Enjin wallet app on my mobile. I'm going to go to the Linked Projects tab, and then scan that QR code. Okay, confirm that. And now we're linked. So if I refresh the page, we should see my wallet address pop up. There we go. Great. So jumping back to the assets page, let's create our first asset. Let's make some coffee. I'm going to make it a fungible asset, an infinite supply, small amounts of Eng, make it always transferable, no transfer fees required, and there's no mail fee either. We need to set a starting supply, so I'll just start with 100. So I've created the blockchain transaction request, and now I'm going to switch back to the wallet app so I can sign it. I find that under the request tab within the Enjin wallet app. So I'll confirm that create within the app. That's signed the transaction, and it's going to send it back to Enjin Cloud. And as you can see up here, we get a notification saying it's been broadcast. And that's been created. This page then automatically refreshes to show us our new asset. Brilliant. So now we have some coffee, we can then mint it. So we've got a mint button over here. If we click that, it takes us to the Enjin Cloud minting page, where we can set the quantity we want to mint and the wallet address we want to mint it to. I'm just going to mint it straight to my own wallet here. Hit the mint button over here. Again, what that's done is created a blockchain transaction request on the database, and that will now pop up in the wallet app. And I can confirm that mint. All right, that's confirmed. We should see some notifications again up here saying it's been broadcast. There we go, copy has been minted. And the numbers here have changed to reflect the fact that we have now minted 1. So reserve has dropped by 1, and there's 1 in circulation. And if we take my wallet address and pop it into Nginx, you can see indeed I have 1 asset here. It's unnamed because we're using the test notebook, and it doesn't automatically sync data. So that was using the web interface in order to create and mint an asset. So let's take a look at some of the GraphQL queries that will be run under the hood there. And for that, we can switch to Postman. So the GraphQL has various schemas, and we've been using the project schema to do this. Now, the first thing we need when using the GraphQL queries directly through to the API is our access token. When we're using Enjin Cloud, it's already created these auth tokens. However, if we're accessing it externally, like we are about to, we need to create our access token first. And to do that, we need to use our project ID and our project secret. This can be found in the settings. We've got project ID here. And we can take our project secret and paste that in there. When we run this query, we'll get back our access token. So to copy that access token, and I'm just going to drop it into the authorization headers as a bearer token for our subsequent queries. Perfect. Okay, so let's start off with creating a new item. I've already written out the mutation that we need to do this here, just to save some time. And I've provided some data in the variables over here. As you can see, they're all the same inputs as we saw on Enjin Cloud. So the supply model, melt values, total supply, name. And I've set that data over here. When we run this query, we will get back a transaction with an ID and its state. The state should be pending in this case, ready to be signed. So I'll send that through. There we go. So now if I check the wallet app again, I can see I have my create transaction ready to sign. So I'm going to sign that now. Okay, that's gone through. And if we go back here, we can see we get notifications again. Perfect. If we check our assets page, we can see we now have our cookie and we have its item ID. So we'll need the item ID now in order to be able to mint. So I'm just going to copy the ID from here. Okay, let's move on to the next tab. I've already created the mint mutation here, and I can just drop the asset ID in, how we know it. I'm going to be minting from the creator wallet, so I need to supply that. And the mint is an array of wallets we want to mint items to. So I'm going to mint 2 of our cookies to my wallet address. So I'm going to send this off. Here we go, we have a new pending transaction. So back to the wallet we go. Confirm that transaction that's just popped up. And once again, we get some notifications within Azure Cloud, so we can see it working. Great, my cookie's been minted. If we check Nginx again, we should see now. There we go. I've got 2 cookies. Again, it's unnamed because we're just using the test network for now. So that's a couple of the underlying queries used to create and mint the assets directly using the API. So let's take a look at the next stage, which is using this mint query within the Node.js app. Okay, so I've got a Node.js app already set up. I'm using the Express.js framework and Axios to do web requests to the API. I'm also using Alpine.js and Tailwind for the front end, which looks like this. Okay, switching to the server first. We need to configure the access token and also our wallet address. So I'm just going to switch here to Postman, grab my wallet address, and I'm going to use the access token we've already created. Of course, you could also use the auth project request as we did before in order to get your access token, but we'll just hard code this one here for now. I've already set up a route, and this route will allow the front end to send the asset ID and who we want to mint to through to the mutation. The mutation you can see is set up here. It's exactly the same one as we used in Postman. We'll take the variables of the wallet, the asset ID, and again a little array of mint requests. So who we want to mint to and how many we want to mint. And here's where we make the request to the Enjin Cloud API using the project schema as before. And when we get a response back, we can send that back to the front end in a JSON string. So switching to the front end. In the client, we've got some variables here to hold which asset we want to mint, and the Ethereum address we want to mint to, and just some variables here to hold some data to show as a pop-up message. Enjin Cloud uses Pusher to send events to and from the API. So we can subscribe to those events using the Pusher library. We need to place our project ID in here so we know which channel to subscribe to in order to get the events that we're interested in. So I'm just going to grab my project ID and pop it in there. And we're going to bind to the token minted event. So when Enjin Cloud sends a token minted event out, we'll get a notification with some data that we can then display to the user. And finally, I've created a small mint asset function here that the front end can call. And this will send a request to the server using the asset ID and the Ethereum address. You'll then wait for its response from Enjin Cloud. And if we've got a pending request successfully come back, we can show a little message to the user for that too. Okay. Onto the front end. I've got a drop-down list with some assets in already, but we'll need to add our new one that we created earlier into it. We could, of course, build this list dynamically using a get assets query from Enjin Cloud. But for now, I'll just hard code it. We'll need to grab the asset ID that was created. So we can get that for the mint that we did earlier. Let's put that in there. Great. Save that. Make sure everything's saved. And then when we refresh here, we should see our cookie. I'm going to use my Ethereum address again. And this time we'll be minting 3 cookies. So I'll hit the mint button. Get a message saying we're minting the cookie. So that's my cue to go to the Enjin wallet app and check the request tab again. And I can see I've got the mint transaction ready to go. So I'm going to confirm that. Okay, that's been broadcast. Now we'll just wait for the message to come back to say it's been minted. There we go. My cookie has been minted. Once again, we can have a quick look on Nginx, and if I refresh, we should see I now have 5 cookies. So there you have it. That's taking the mint mutation that we created earlier and using it within the context of a Node.js app. And that's pretty much all there is to it.
There it is. So I hope the audio came through okay on that. Oh, you're muted, Witek.
There we go. Thanks, Simon. That was great. So obviously, doing code on a webinar, if you're a developer, that might be interesting. If you're not a developer, maybe it was a little bit boring. But let me just kind of explain what we did there. So on the Ethereum blockchain, we have a smart contract that's using the ERC 1155 standard, which lets you create assets, mint assets, transfer them, and assign all sorts of things to them. So we actually have an API built on top of that. So you can obviously talk to the blockchain directly, build your transactions, and tell the contracts to mint those things. Or you can use our API, for example. So Simon actually went in, used the GraphQL API, formed a query, and told it to mint a coffee and a cookie. Then he went in and he created an app in Node.js that actually let you do that using a very simple interface. And if you take that further, you can build your own interfaces, whether it's in a game or in a mobile app or in any kind of system. I can actually quickly just share what Microsoft has done with it. So I just shared my screen here. This is the Microsoft Azure Heroes showcase. So those badgers, that QR code that I showed you earlier, you can actually take that badger that you received and link your wallet up to this website, and your badger can display here right on the map. It'll get your geolocation, and you can actually link your Twitter, you can link your social profile in with the website. And then this is using the same APIs that that Simon was talking about. So this whole app was built on our platform. We clicked on Sweden, you can actually just see that these are the people who got various badges in Sweden. So it's a very powerful system, and you can just see how you can extend this, build apps, powerful apps on top of this. With the same API, you can transfer things, you can apply metadata, you can attach history and change images and do different things to your assets. So that's a really powerful system, and each one of these tokens is fully decentralized. If somebody owns it, they own it forever. They'll probably own it for 1,000 years. So that's sort of an overview of what we're doing, and I think we can go to Q&A now.
Yeah, thanks a lot, Witek and Simon. Very interesting from my side. I may have some questions, but maybe asking to the audience first, if somebody has some questions about what we just saw, or in general about the topic. Just unmute yourself. All right. So maybe I start with my question first. So you mentioned a little bit of the that you're providing SDKs on top of that. So what we just saw, if I was getting that correctly, was you were directly using the REST API. So is the SDK something that you provide like on top of that makes it even simpler for developers to build this kind of apps?
Yeah. So the API that we have is actually a GraphQL API. So it's actually a lot more powerful than REST. GraphQL lets you like form your queries and create these things called mutations. You can edit very specific data. You can also retrieve exactly the data that you want versus REST, which is a little less flexible. And so we do provide a bunch of SDKs that you can just plug into your existing app, and they will talk to our API. So they actually remove another layer of complexity. You can just ask them, what tokens does this user have, and they'll just spit it out for you. And everything in the back end, what our API is doing, it's listening to the blockchain at all times. And when anything happens with your tokens, it sends out that notification to your app, and then your app can respond to that. What we're doing in the near future, we're actually going another step further and creating an API that you can host on your own backend. So then you can directly integrate that into your servers, and your servers can directly talk to the blockchain, and that allows a lot more flexibility and customization. That will probably be coming next year.
Great.
Also, so Kevin, I think, had a question.
Hi, yeah, I was just curious to see how you attach metadata to these tokens as you mint them.
Sure. So there's a few kinds of ways you can do that. The most common and popular way to do this is off-chain metadata currently, and we're working on solutions for on-chain metadata with different companies like IPFS. So off-chain metadata means you have a JSON file, and there's a standard. If you look up ERC 1155, there's actually a JSON standard that you can use. You can put your image in there, you can put your name, description, and you can put any kind of random metadata you want. So if you have, a Magic the Gathering card, you can put in all its, all its values there, what firepower it has or whatever. Yeah, generally what you do is you create these JSON files, you put them up on a server or on IPFS, and then you can on chain you put the URI that points to that JSON file. So what that does is obviously if you host the metadata on just a web server, that that isn't immutable. Somebody can change that. So people have had concerns about off-chain metadata. So what we're doing with IPFS into the future is having mechanisms to actually bake the metadata into the items and make that really efficient. So you could have hundreds of items on IPFS and easily do that without spending too many transaction fees. Another thing you can do with our platform and our APIs is this thing called add log. What it does is it lets any wallet in the world append some on-chain metadata to an item. So let's say you have this epic battle hammer, and then you go up to PewDiePie, and he signs your epic battle hammer inside the game or something like that. He can use his wallet to send a signature out that attaches itself to that item, and that gets logged. Now, any future app that looks at that item can check its logs and say, "Oh wow, PewDiePie, signed your hammer," and it can maybe start glowing purple or whatever it is, right? So that's something. It's not been explored yet too much in the NFT space because of high gas costs. People don't want to be putting too many transactions on chain, but I think in the future this is going to be a huge thing for items.
Yeah, that sounds interesting. Yeah, move chain, guys.
Yeah, we are. So we're currently working on a chain called Efinity. This is built on the Polkadot network, and the intention is really resolve gas costs. We have various mechanisms of doing that. Create an economy that's not tied to miners and that whole thing that Ethereum and Bitcoin have. It's an economy that's fully contained within the NFT ecosystem. So people who are using NFTs, people who are trading NFTs, people who are doing price discovery, they're all providing economic inputs and providing value in certain ways, and maybe getting tokens for doing that. So we believe that that the structure we have for Efinity will make things orders of magnitude cheaper, and then you can do crazy game things like running around in the game, picking up tokens, getting that all logged in the blockchain, putting metadata on them, signing them. And yeah, we're also trying to solve interoperability issues. Our new token standard is going to connect to Ethereum and other blockchains, let you move those NFTs around, and they'll still stay. People will know where they came from. They'll have a unique ID that will stay across chains. So we're really looking forward to that over the next 6 months.
Okay, thank you.
Great. So maybe another question from my side. So you mentioned a little bit. You brought an example that we did that you did with us with Microsoft with the Azure Heroes NFTs, and it's a gamification approach for skilling and for contributing to the community. And you also brought a little bit of these examples with the gaming in-game currencies and things like that. Are those the typical use cases, or maybe talk a little bit about what other customers or things you have, or is it really you focus on this particular space with your technology and with your product?
I think this is very abstract and just kind of generic technology that you can use for so many things. I mean, just the concept of having ownership of something and having full access to the data, who owns something, who applied metadata. That's something you can work with for a long time and come up with a million use cases. So we talked about gaming. There's many different ways to use this in gaming, whether it's currencies, owning items, actually having things as part of the gameplay, where people put their tokens together and then use them as part of the gameplay. We're also as with Microsoft, we're using it to gamify businesses and enterprises. There are uses in supply chains. If you want to know where your coffee came from or where your produce came from, maybe in 5 years we'll see every farmer's market will have a QR code on each stall, and you can actually track where the produce came from. People have been over the last 6 to 8 months. Celebrities and influencers have really gone crazy with NFTs. They've tokenized just about everything under the sun. Their brands, their unique pieces of artwork, their music. So you can use this for limited edition. Saying that you have this original print, digital print, and I think it's hard for people to wrap their heads around this concept of owning a digital item still. But in some ways, if you think about it, physical items can deteriorate. There's entropy. Digital items can't. And I think there's a lot you can do there when you actually know that the creator has put their stamp on it. And then we can use that digital item in future experiences, and you can show it off in virtual worlds, or you can put a hat on your virtual character in AR and VR, which I think we're going to see a lot more of in the next decade. That's going to be a really cool use case for people. So I think we're going to see a lot more of this, open market, open data. I can't wait to see more people building websites and interfaces to tap into history, so you can actually get such amazing market research. If you see, what's been happening in terms of markets, trading, gaming, you can see what's been happening with those items, what items are most popular, what users and what regions are doing things. I think that's going to really, when you apply some machine learning to that and then show that in beautiful UIs, it's going to be pretty amazing.
Great. So maybe last question from my side that I had to say. If I'm a developer and I just want to get started with what you just saw here, so what do I need? So is there a do I need to join your developer program? Do I need to get a platform license or something from you to use it, or to join your platform, or how is it working? How could I become somebody building an app with your platform and with all that we just saw?
Sure. So you actually don't even need to know much about programming smart contracts or Solidity. You can go take a look at our documentation on engine.io, and that will point you to our Enjin cloud platform, which is at cloud.engine.io. And you can actually just sign up there for free and get started. There's no licensing required or anything like that. Now we have some programs that if you are a serious developer that's putting building a really complicated, interesting project, we'll work with you, we'll support you, whether it's game development or something else. We work with dozens of developers in different spaces, and we provide support, development support. We may even provide some tokens and things like that to help your project build out on the platform.
Okay, great. Yeah, thanks again. So very interesting. If nobody else has any questions, I'm really.
Sorry, I have a question.
Sure. Thanks.
When thinking about those tokens, especially in games, I'm always looking back at a friend who was really addicted to World of Warcraft. If you scan the games, I mean, don't you think that you guys or this NFT business needs some kind of a blockbuster to really skyrocket, because the games available are like, well, okay,
Yeah.
Are there any plans? I mean, those are big players in the market. It would be crazy to have this fancy purple hat in World of Warcraft as an NFT.
Yes. So this is actually, we started this, we had this idea and this concept back in 2017 of doing NFTs in the blockchain space. And we knew that there's something powerful there. So we went and rented this huge booth at Game Developers Conference in San Francisco. We did that for 2 years in a row, and we ended up talking to hundreds of game developers there, both indies and larger game devs. And back then in 2018, everyone was worried about risk. We're spending millions of dollars on a video game. This hasn't really been proven. How are people going to get Ether? Things like that. They had all these friction points that they were hitting. So we were able to get some indies interested. I think that we have like 40 to 50 indie developers building on our platform. A lot of the games have actually been released. So they're more willing to take risks. They took the first step into the NFT space. Some of them are actually generating substantial revenue from their aftermarket trades and selling items and things happening inside their game. Now, after this sort of influencer, celebrity, art, NFT craze has happened over the last half year, everyone knows about NFTs. I would say hundreds of millions of people around the world know what an NFT is. My grandma knows what an NFT is. She's 80. So now we're a
cool grandma, I think.
Yeah, well, yeah. My grandma's really crazy. She's better at computers than my parents are. But anyways, so what happened is now the general awareness of what NFTs are, and that people will actually pay for these items. And it's been proven now with these influencers and artists. And so we are actually seeing game publishers, and we've seen this a little bit in the past, like people like Ubisoft were the first experimenters in the sort of large game publisher space. They went and they tried to make, you know, various experiments in blockchains. But now we're seeing real publishers and real AAA game developers come in and say, wow, we think we need to get onto this NFT thing. We need to do something with this. This could be huge in our games. So we're seeing things, we're talking with like literally large AAA devs. Some of them are doing just, you know, social items, things like hats on your characters. Some of them actually want to implement it directly into their gameplay and do some creative things. And I think there's a lot of creativity you can do there. When you add that element of ownership and risk inside of a game, where you can risk losing a token, and you can gain something if you defeat the other team, for example, that adds a huge amount of, you know, sweat and interest into the gameplay. So we're seeing that happen now, and I think you know, as these games come out, probably in the next year or two, that we'll see some large publishers come out with their blockbuster games. And then I think we're going to see a large wave of indies, because we know that there's hundreds of thousands of indie game developers out there in the world. And then they'll see it proven in both the indie space and in the large space. And then we're going to have a lot of people trying to use this, because monetizing, I think, is a lot more interesting nowadays. You have mechanisms like Kickstarter, Patreon, for monetizing different things. And I think blockchain is going to add a new way to monetize games and bring your most loyal user base in when you're developing the game. Get them some tokens, get them some items, and then, you know, they can use that in the game afterwards. So we're going to see that developing now that all the tools have started becoming more mature. And with Efinity, we're actually trying to knock down some of those those barriers that people have had. So people will be able to just join a game, start playing, receive items, and not have to know that they're even interacting with crypto. So I think that's going to be the game changer.
Great. Yeah. So maybe last question from my side. So how is it? I'm just imagining, for example, if I think about games, let's stay with that example a little bit. Is there a scalability issue in terms of minting and also in general, let's say scalability in the broadest sense? I just think about, let's say, EA Sports and the FIFA games with like all these this packs of players. I can just imagine there's a huge amount of tokens out there, and I don't know how they manage it today. But if you want to sell this to the publishers or to the AAA studios, what's your answer to this? Let's say scalability problem, or let's say, yeah, is it a problem, or what would be your answer to that?
Yeah, there's two things. There's the cost aspect, and then there's the scalability aspect, which is throughput, how many transactions can happen per second, and they're kind of interlinked. So right now, you know, we've had version 1 blockchains like Bitcoin, where it's literally just, you know, tokens, Bitcoins being moved around. Then we've had, I would say, V2 of blockchain, which is things like Ethereum and EOS and all these other kind of programmable blockchains. And these still, like, especially Ethereum, still operate off proof of work. They're incredibly secure because of it. They have, you know, a huge amount of developers using them, but transaction fees can cost dollars, a few dollars, just to send a token to somebody. Now, a lot of the game developers that are in this space right now, they are kind of subsidizing that cost. You know, if they're sending an item that somebody's purchased for $100, they're okay with paying $5, $6 or whatever it is for that transaction fee. And then when the user has the item, they can access the data on the blockchain for free forever, right? But what we want to see is more scalability in transactions, because we've had these exact conversations with the larger game publishers. You know, we're going to bring in millions of users. How are we going to send out millions of tokens without it costing millions of dollars? So there's a few ways to tackle scalability, and we're building our new blockchain, this interoperable parachain called Efinity, on the Polkadot network. Now, one thing it does is it uses nominated proof of stake. So it's not limited by proof of work. It's infinitely cheap, like not infinitely, but it's orders of magnitude cheaper, minuscule fractions of pennies to do transactions on there. It can handle currently 1,000 to 1,500 TPS. So it's a lot more than Ethereum or Bitcoin are doing today. And you can also batch transactions. So if you want to send 100 tokens or 500 tokens at once, you can lump them all in together in one big transaction. The other aspect of scaling throughput is moving into either sharding or layer 2. So sharding means separating tokens into different chains or different ledgers to separate those concerns, having more nodes handling separate things, just like sharding a database would be. And layer 2 would be doing a number of transactions off chain and then committing some sort of proof to the main blockchain. So you could do 1,000 transfers within a game session between people and then committing that proof to the blockchain. So these are all things we're tinkering with and exploring. We know that on the base layer, Efinity is going to handle a lot more than Ethereum could. And we're already trying to build it in the way that we can add on these sort of two methods of scaling even further when we have those people doing tens of thousands, hundreds of thousands of transactions per second, which we're not quite at yet, but in the next few years it might actually happen. So.
Another question. So I don't understand it as a provocation, but why build another blockchain if there are other blockchains, like take the Solana network, for example, with I think 60,000 TPS. I think there are chains available which are not limited in that way. Why do your own?
So actually what we're doing is we aren't building so some people go and either fork an existing large blockchain and build their own or just build one from scratch. We are actually building on the Polkadot network. So we are going to stay connected to the entire Polkadot community. And if you guys are aware, Polkadot was developed by Gavin Wood. He led this project, and he was actually one of the original inventors and founders of Ethereum. He invented the Solidity programming language for smart contracts. He wrote the Ethereum yellow paper, the technical paper. And he was responsible for one of the most popular wallets on Ethereum. He has a lot of clout in the space, and he went off and he realized that this would be a problem on Ethereum because Ethereum is just like a one giant computer that everybody's trying to pile all their transactions into. What he's doing with Polkadot is building an internet of blockchains where each chain has different things that it specializes in. One might be great for supply chains. One might be great for some kind of unique DeFi thing. We're building our parachain on this network. It's going to be hyper optimized for token transactions, for non-fungibles and fungibles, minting them, creating them. All the protocols are going to be hyper optimized for that. Multi-sig is going to be built in by default. And we looked at a lot of solutions. I mean, we've been thinking about this for years now, and we've actually gone quite far in the past with building on, firstly our own layer 2. We went quite far with building our own layer 2, and then we were exploring all other blockchains. And we found the approach of Polkadot to be probably the most superior in the space because it remains connected. There's a lot of projects that keep it connected to Ethereum, so it's not going to be this thing off by itself. You can bridge tokens in using things like Snowbridge, Snowfork. You can bridge them back out to Ethereum, and building these blockchains that are hyper optimized to your use case could be the future. So we're building a token standard on Polkadot that will work across that whole ecosystem so people can move their tokens easily in between chains, interact with all these different parachains that do different things. And I think that could be a really interesting future for NFTs.
Makes sense.
Yeah, it makes sense. But which blockchain are you targeting? I mean, DOT is just an interchange protocol, right? So
So here's how it works. Polkadot is a collection of parachains. So you build them using the Substrate framework. It's this framework for building blockchains. And Polkadot itself has this thing called a relay chain. It handles the security, the major consensus and security and validation of the network. Each parachain connects to this main relay chain. They basically have a portion of the security. It's like you have a parking lot in downtown, right beside an arena with 100 parking spots, and you have one of those parking spots, and you can use that security. You can use that security of the main Polkadot chain. Your parachain doesn't have to actually worry about the security. So as we were building Efinity, we can actually focus on building a unique economy that is not limited by external forces. We can build that economy to be all for NFT creators and people who are providing value there. Does that make sense?
Yeah, I know how top works, but I'm just curious to know what you're going to be using as your underlying implementation. So Affinity is yours.
Yes,
it's yours from the ground up, right?
Yeah, we're building it on Substrate.
Okay.
Building in collaboration with the Parity team who's building Polkadot.
Okay.
Yeah, and we are working on a token standard that's going to be a public thing. We've been talking about releasing it over the last month, but we're getting close. We're still refining it before we kind of reveal it out to the public, and then we're going to get all the community's feedback. See, get them to. We were hoping everybody's going to tear into it and see what problems it has, just like we did with ERC 1155. So the entire community, the entire blockchain space, can agree on something that they want to use into the future that's abstract and future-proof enough.
Yeah, I like the approach.
So what's the new timing for Infinity?
So Infinity, we're looking at releasing around the end of the year, the actual parachain. But the token standard is going to come earlier. So we're still, before we unveil it, we're just polishing it up, just running through some more internal, polishing up there. So it might come out in July, the token standard, and it'll be on the Substrate Open Working Groups GitHub.
So when it comes to your tokenization standards, do you see anybody using Enjin to do something like tokenize assets? And if so, why would people decide to tokenize using Enjin tokenization standards compared to, for example, Ethereum or Cardano with their Alonzo network? I think you've already touched on it slightly, but.
Sure. So I talked about the token standards earlier. So there's ERCs 20, ERC 721, and 1155. We're actually seeing that 1155 has started to be picked up. It might be becoming one of the most popular NFT standards in the world. Essentially, it's way cheaper to mint things. You can do even some sort of you can build a contract that you provide like a bundle of data where the user can mint it after they purchase it. You can really optimize the cost. So we're seeing all the NFT marketplaces now supporting 1155. We're seeing a lot of wallets starting to support it. And it's just made better for things like any kind of real world use cases, games, supply chains, anything you want to do, enterprise. ERC 1155 makes more sense. So now in terms of the next token standard that we're doing, it's going to be backwards and forwards compatible with ERC 20, ERC 721, and ERC 1155. What we're focusing on with this new paratoken standard is how do you define an ID that anyone in the world can recognize? Like, you have analogs like a UUID, that's a unique global ID that you can use. We're trying to create an ID that you can figure out what network the token came from. If it gets bridged onto different networks, you'll be able to retain that this is the actual NFT. We're talking about how to do these bridging, what kind of monetary policies that people that implement these tokens should follow. Like, how do you know whether you're allowed to mint these tokens or what the total supply is or different things cross-chain. It's really difficult to do cross-chain when you have maybe multiple chains minting tokens of the same type. So we're trying to solve all these problems in the new paratoken standard. And it's going to also include some detail on, for example, XCM, which means you have this internet of parachains. If you want to do something with your token on a different parachain, you can use XCM. And we're fleshing out the standards on how that all works together. So, there's some basic standards that people have been doing on Polkadot. Even there's I think it's called Remark is a Kusama NFT standard, but it's very basic and it's not optimized. It only allows for sort of simple NFTs. What we're trying to do here is something that you can build future-proof apps on. Does that answer your question?
Yeah, thank you. Just one more thing on that. I'm assuming that, as you guys are developing your token standards and everything, just like the ERC 20 standard, will you be able to whitelist your fungible tokens and NFTs?
So do you mean white label or whitelist?
Whitelist, so that they'll only be able to be sent to certain wallets.
Yeah, I mean that's completely up to how you develop your tokens. So we actually have this baked into our current engine ecosystem, where you can do whitelisting. You could also, just as a developer, you could code a token using one of these standards and make it do anything you want. You could make it collapse over time. Like you could make an ice token that melts and it just melts away if you don't use it. You can do all kinds of. You can implement your own policies in your own code, because it's just fully open. The standard just defines like the very abstract basics of what a token is. How do you identify it? How do you move it around? How does it move cross-chain? Can you attach images to it? All that kind of stuff.
Great.
You can bake
Thank
any
you.
code around that. Yeah.